Hey and welcome gurus to this lesson introducing Azure Load Balancer. We're going to start off by describing what Azure Load Balancer is. And then we're going to get into comparing Azure Load Balancer to traditional on-premise environments that do the same thing. Then we're going to go over the components of an Azure Load Balancer. And then we're going to go through a demonstration where we're going to be creating a load balancer inside of Azure. So let's get started. To begin describing Azure Load Balancer, it's best to think of it like any load balancing solution, right? We use it to balance traffic between back-end compute. And in the case of Azure, what we're talking about are virtual machines and virtual machine scale sets. Now, the virtual machines can exist in availability sets as well, but the idea here is we've got this back-end compute and we want to distribute traffic between this back-end compute to serve a common purpose. Like, say, for example, a web server, right? We'd have a back-end compute set of virtual machines that offers up the same web server and website. So that way we can use the load balancer solution to balance the traffic for that single web solution. Now, what we're talking about with Azure Load Balancer here is layer 4 balancing, right? The TCP UDP. We're talking about port 80. We're talking about port 443 for HTTPS. And what we're providing is a redundant and highly available backend compute solution to serve the same purpose that is all going to be routed through this Azure Load Balancer. And these backend resources have to be redundant, right? Because otherwise there's no point in configuring the load balancer to balance the traffic between the backend compute. We would just use one virtual machine. But what we have to have here is this redundant number of backend compute nodes that we can use to serve the same purpose of our solution here, like our virtual machines and our virtual machine scale sets. Now, to compare this to traditional load balancing solutions, what we have are a lot of the same features inside of Azure. We have the virtual network, right? Of course, it has our compute solution like our virtual machines, and these act as our back-end compute here. And what we do is we create a load balancer, and this load balancer comes with a public IP address that makes it accessible over the internet. And using this load balancing solution, we can balance traffic that's coming in over the internet between our backend compute. Now, we don't have to just use it for a public load balancing situation. We can use it for private load balancing, right? Internal traffic. It doesn't have to just be external from the public internet. It can be internal within our own networks. We could have it balancing, say, a database solution as an internal load balancing solution for a application that we're running, right? We could run that privately inside of our network. It would balance internally, which we'll see in our demonstration. Now, the components that make up our Azure load balancing solution are, of course, first we have our virtual network. And in our virtual network, we can deploy our load balancer, right? And when we deploy our load balancer, we also are deploying a front-end IP, a public IP configuration in the case of an external load balancer. And if it were private, we wouldn't have a public IP, but we'd have a private IP. But either way, we have an accessible either public or private endpoint for the front end IP of this Azure load balancing solution that we have here. And then we have our backend pool, which is going to be our compute underlying the load balancer that is going to be balanced between for the traffic that we have incoming to this load balancer. And then we have a health probe that we create that is going to check the health of our backend compute to make sure that it is running appropriately based off of the health checks. And once it's determined that they're good to go, we have those available nodes in the background. And should one be unavailable, of course, we'll know that because of our health probe. And then we have our rules. And our rules are things like our load balancing rules that tell how we're going to balance traffic between our backend compute, or our NAT rules for both inbound and outbound rules to allow access over things like SSH from our public IP address of our load balancer, and then NATing that to one of the backend computes inside that load balancer. Alright, gurus, now what we're going to do is make our way into the Azure Cloud Sandbox so that we can get started with this demonstration. Alright, gurus, here we are in the Azure Cloud Sandbox, and to get started with this load balancing demonstration, what I have here is a virtual network, and inside of this virtual network I have two subnets, a default and a private, and inside of each of these subnets I have a virtual machine that has a network interface. And what we'll see on both of these network interfaces is that we have no public IP address here. See, we have no public IP. And we go and look at NIC2 here, we have again no public IP address. Now both of these virtual machines are running web servers, and I want to be able to access them over the internet using my load balancer. So the first thing that we're going to
Sorry, we have one. Car Challenge 2023. We have out here full of 150. like that. You will be eliminated if you do that, okay? Like that. You will be eliminated if you do that, okay? Like that. You will be eliminated if you do that, okay?
Do here is come up to our search bar. We're going to type in load balancers, and then we're going to select it under services. We're going to click create here, and then we're going to minimize this portion of the blade and begin configuring our load balancer to balance that layer 4 traffic for our web servers here. We're going to select our resource group, and then what we're going to do here is give it a name, LB-01, and then we select our region, and we have to select the same region as our virtual network that has our backend compute. And in my case, it is Central US, so I'm going to use that. And then we can select whether or not we want to use this load balancer either internally or publicly. Now, publicly is going to provide it a public IP address that we can use to access it over the public internet. So this is going to be our option here. And then we can select our SKU, and we see we have either standard or basic. Now, what we're going to see is that standard is going to be what we want to use for any sort of production workload per Microsoft's recommendations. And what we see the differences are in this tab that I have open here is that we have support for up to 1,000 instances for the standard and only supporting 300 instances for the basic. Now, another key difference is that standard is going to allow us to have a backend pool of endpoints that consist of a mix of virtual machines and virtual machine scale sets inside of a single virtual network. But with basic, we have to choose either a backend pool consisting of either virtual machines or the virtual machine scale sets and not a combination. And then with standard, we get support for health probing on HTTPS, and we also have a zonal redundant load balancer when we use standard, as availability zones is not supported with basic. And then we also have to keep in mind that because we're getting a public IP address that is standard with our standard load balancer, it's going to be secure by default, so we have to use a network security group, as we've talked about in previous lessons with standard public IP addresses, to make this load balancer accessible. And the basic is going to be open by default because it uses a basic public IP address, and we can secure that with network security groups. So those are the main differences, and again, we get that 99.99% SLA with standard, and that's what we're going to want to use in most production workloads. So we'll come back to the other tab here, and it is selected as standard, and we see we get to choose between either a regional or a global. Global is going to allow for a cross region, but we'll go with a regional here. And then we're going to create our public IP address here because we don't have one. We're going to call this our LB-PIP. And as we see, it's going to give us a standard SKU public IP address with the static assignment. And then we get to choose our availability zone or zone redundancy for our load balancer here. We'll go ahead and choose zone redundant. And we can choose whether or not we want it to provide an IPv6 address. We'll select no. And we can change our routing preferences between either Microsoft Network or Internet. We're going to use Microsoft Network here. And then we're going to click Review and Create. It'll validate the deployment of this load balancer. We'll click Create, and it's going to go off and create our load balancer for us. So we'll be back once this resource is done provisioning. Alright, Gurus, so we're back, and our load balancer is done provisioning. So we'll go into this resource here, and the first thing that we need to do here is take a look at our front-end IP configuration. We have that public IP address, and now we need to go to our backend pool here and configure our backend pool for this load balancer. We're going to add a backend pool here, and we'll call this our web-pool since it's load balancing a web solution here. And then we're going to select our virtual network. And again, our virtual network has to be inside of the same region, otherwise we won't see it here. So I'll select my virtual network, and we can choose to configure our backend pool based off of either its NICs or IP address. We're going to use NIC here, and then we're going to support IPv4, and then we're going to add our virtual machines or virtual machine scale sets here. Now we don't have any in central US, so of course we're not going to select any virtual machine scale sets, but we can add a mix of both of these here because this is a standard load balancer, and that's not something that we can do with a basic load balancer. We're going to add our virtual machines here. I'm going to select both of these, and then what I'm going to do is add them, and it's going to add them both into the backend pool based off of their private IP configuration here. And they're not inside of an availability set, as we can see here, but they could be if we needed them to be. We'll click add, and it's going to add this backend pool to our load balancer here. So now we have a backend solution for our load balancer so that we can balance traffic between both of these virtual machines here. Now we're not done here. This is only configuring the backend pool. What we're going to be configuring next is our health probe, and then we're going to configure the load balancing rules that determine how we're going to balance traffic between the virtual machines inside of this backend pool. So we'll be back once this backend pool is done provisioning. Alright, Gurus, we're back. And our backend pool is done provisioning for our web pool here. Both of these virtual machines are in a running status, and we see that they're not in either or cross region, but we'll go with regional here. And then we're going to create our public IP address here because we don't have one. We're going to call this our lb-pip. And as we see, it's going to give us a standard SKU public IP address with the static assignment. And then we get to choose our availability zone or zone redundancy for our load balancer here. We'll go ahead and choose zone redundant, and we can choose whether or not we want it to provide an IPv6 address. We'll select no, and we can change our routing preferences between either Microsoft Network or Internet. We're going to use Microsoft Network here, and then we're going to click review and create. It'll validate the deployment of this load balancer. We'll click create, and it's going to go off and create our load balancer for us, so we'll be back once this resource is done provisioning. Alright, Guru, so we're back and our load balancer is done provisioning, so we'll go into this resource here, and the first thing that we need to do here is take a look at our front end IP configuration. We have that public IP address, and now we need to go to our backend pool here and configure our backend pool for this load balancer. We're going to add a backend pool here, and we'll call this our web-pool since it's load balancing a web solution here. And then we're going to select our virtual network, and again our virtual network has to be inside of the same region, otherwise we won't see it here. So I'll select my virtual network, and we can choose to configure our backend pool based off of either its NICs or IP address. We're going to use NIC here, and then we're going to load balancer. We'll click create, and it's going to go off and create our load balancer for us, so we'll be back once this resource is done provisioning. Alright, Guru, so we're back and our load balancer is done provisioning, so we'll go into this resource here, and the first thing that we need to do here is take a look at our front end IP configuration. We have that public IP address, and now we need to go to our backend pool here and configure our backend pool for this load balancer. We're going to add a backend pool here, and we'll call this our web-pool since it's load balancing a web solution here. And then we're going to select our virtual network, and again our virtual network has to be inside of the same region, otherwise we won't see it here. So I'll select my virtual network, and we can choose to configure our backend pool based off of either its NICs or IP address. We're going to use NIC here, and then we're going to support IPv4, and then we're going to add our virtual machines or virtual machine scale sets here. Now we don't have any in central US, so of course we're not going to select any virtual machine scale sets, but we can add a mix of both of these here because this is a standard load balancer, and that's not something that we can do with a basic load balance, as we can see here, but they could be if we needed them to be. We'll click add, and it's going to add this backend pool to our load balancer here. So now we have a backend solution for our load balancer so that we can balance traffic between both of these virtual machine probe, and then we're going to configure the load. Alright, Gurus, we're back. Up here is creating our health probe, so we'll click on health probe here. We're going to add a health probe, and we're going to name this our web probe here, and we're going to check a port 80 for an interval. Probe is going to let us know, of course, that it is unhealthy. Now if we would have selected the protocol for HTTP, what we'd see is we could specify TCP, and we'll click add here, and it's going to add that health probe so that we can health check our backend compute behind how we want to balance traffic here. We'll click add for our load balancer here. The load balancer to make sure HTTP balancer front end IP is what we want to use as the front end for this load balancing solution, and then we'll choose between either a probe checking for TCP 80, and now we can choose what, that way you can stay with that same virtual machine the entire time throughout your session here. I'm going to choose none here, and then what I'm going to do is come all. And again, something I want to touch on is that we have, of course, with our standard load balancer, inbound NAT rules and outbound rules that we can use to configure DNAT and SNAT. For example, if we want to be able to SSH into the backend compute here, we can use our inbound NAT rules to create that rule to allow that network address translation for our SSH traffic from the front end IP of the load balancer. Now, what I want to check here is how our load balancer is doing and make sure that we can access our resource here. So we're going to copy this IP address of our load balancer, and we're going to paste it into the browser. And what we're going to see is we're accessing the backend web servers, the backend compute here, and specifically we've ended up with the first virtual machine, and what could happen is we could have ended up with virtual machine 2, and we're going to balance between the backend compute that we have here between these two virtual machines. Alright, Gurus, let's make our way back to the slides for a quick review of this lesson. For port forwarding for inbound traffic to the nodes in the backend pool, like we talked about with our SSH traffic, so that we can communicate with those nodes via that NAT translation. And then we also have the same for S. Look forward to seeing you in the next lesson. Hey, and welcome, Gurus, to this lesson using Application Gateway where we're going to begin by describing Azure Application Gateway. We're then going to compare Azure Load Balancer and Application Gateway so that we understand the differences between the two. And then we're going to talk about the components of Application Gateway, and then we're going to get into the Azure Cloud Sandbox where we're going to create an Application Gateway ourselves. So let's get started. Azure Application Gateway is a load balancing solution inside of Azure that allows us to provide some application awareness for our load balancing. And what I'm talking talking about here is layer 7 load balancing, and with that comes something known as URL path-based routing. So we can have different backend pools for different purposes and route to them based off of their URL. For example, if we had a videos backend pool, well, maybe that backend pool has different compute inside of it because it's going to be doing a lot of encoding. Or maybe we have a labs backend pool that provides the labs like we see here on a Cloud Guru, and it provides that functionality to the website. Now, the backend compute, much like with Azure Load Balancer, has to be redundant so that we can load balance between the compute and that backend pool. And the backend pool for Application Gateway can consist of virtual machine scale sets, and app services, which is something we don't get with Azure Load Balancer. Now, in all this comparing Azure Load Balancer and Application Gateway, I think we need to really break it down here. They're very similar solutions. They're both used in load balancing. But again, what we're getting with Application Gateway here is the ability to have things like app services in our backend compute, and we have things known as URL path-based routing for our backend compute so that we can listen in for the connection to determine where we're going to route this based off of the URLs that we want to use for this path-based routing. Now, the components of Application Gateway consist of our virtual network, where we have to have a specific application gateway subnet that we can use, and that's something that we don't have to do with Azure Load Balancer. And our Application Gateway consists of course, a front-end IP, whether this is for private or public connectivity, either through a private IP address or a public IP address. But actually with the Application Gateway, we can do one or the other, or we can have both if we want to provide private and public through our Application Gateway. And then we have our backend pool, which is going to be things like app services, virtual machines, and virtual machine scale sets, as well as IP addresses and fully qualified domain names. And with our Application Gateway, we also have a listener that's going to listen to determine how to route the traffic to our backend compute based off of that path-based routing. And we also have our certificate configurations within our listener so that we can do things like SSL termination at the Application Gateway. And the final component we have is our rules, where we're talking about load balancing rules, HTTP settings to set session persistence, and our health probes like we have with our Azure Load Balancer to determine if our backend compute is healthy. Alright, Gurus, now at this point in our lesson, we're going to make our way over to the Azure Cloud Sandbox so that we can get started with our demonstration where we're going to be creating an Application Gateway. Alright, Gurus, here we are in the Azure Cloud Sandbox, and to get started with this demonstration, I have a virtual network here inside of the South Central US region, and my virtual network here that I've created for this demonstration has two subnets, and inside of each of these subnets, I have an Ubuntu virtual machine running an Apache web server displaying the host name using PHP on those. And I'm doing this just so that I can determine which one I'm looking at when I visit it via the browser. Both of these have public IPs, and both of them are accessible via inbound traffic for port 22 and port 80. Now I'm going to be showing how I can load balance between either of these virtual machines using Application Gateway. So what we'll do to get started is come up to the search bar and type in Application Gateway and select it under Services. And then we're going to click Create here. And then we'll minimize this portion of the blade and begin configuring our app gateway here. We'll select our resource group. We'll give this Application Gateway a name here, AGW-01. I'll make sure to select the same region as my virtual network here, South Central, and select South Central US. And then next I have an option between my tiers here. I have an option between Standard, Standard V2, WAF, and WAF V2. And what we're really talking about here is, do I want a version 1 or a version 2 Application Gateway? And there's some differences between those. And do I want this Application Gateway to either be the standard, or do I want it to have a web application firewall? I'm going to stick with Standard V2 for this example here. And then the next option is whether or not we want to enable auto scaling on our Application Gateway, and then we can choose whether or not we want to provide a minimum instance count or maximum instance count here. Let's say we want a minimum of 1 and a maximum of 3. But the great thing is that we get with our Application Gateway is the ability to enable this auto scaling. And we also, with our Application Gateway, can choose to do a zonal deployment and we can specify the zones we want to deploy into, but we're going to leave it set to none here. And then the next option is whether or not we want to enable it for HTTP2 protocol support. We'll go ahead and leave this disabled for our demonstration here, and then we'll select our virtual network, and I'll scroll down, select it, and now we need to select a subnet here. Now we need a subnet that will only have the application gateway in it. And so what we're going to do here is click on Manage Subnet Configuration. It'll bring us into our virtual network subnet so we can create an app gateway subnet. I'm going to call this the app gateway subnet here. And I'm going to give this a /27 prefix here so that we have the appropriate amount of space for scaling for this app gateway. And then I'm going to click Save. And it's going to add this app gateway subnet that we need where our app gateway can exist by itself. In a subnet, and then I'll exit out of this here and exit out, and it brings me back into creating my app gateway here. I'll select the subnet, app gateway subnet, and then I'll click next into front ends, and here is where I get to determine whether or not I want to have a public application gateway, private, or both. Now for this queue I've selected, I can't do just a private. I need to either do public or both here. I'll go ahead and just do a public for my example, and then I'm going to add a new public IP address. I'm going to call this my AGW-pip, and then I'm going to click OK, and then I'm going to click next into backends here. And now I need to add the backend pools for my application gateway to load balance between. So I'm going to add a backend pool here. I'm going to call this backend pool my default pool, and then I'm going to choose my target type. I can choose between IP address or fully qualified domain name, virtual machine scale set, or app service. I'm going to use a virtual machine in this case, and then I'm going to select my NIC1, and then I'm going to click add, and then I'm going to add another backend pool here, and I'm going to call this my app pool, and then I'm going to choose my target. I'm going to again select virtual machine out of the options and select my NIC2 here. I'm going to click add, and now I've added those two backend targets that I can route between. Now I'll click next into configuration here, and the next thing that we're going to be doing is configuring our routing rules. And in our routing rules, we're going to give our rule a name here. I'm going to call this the multi-path rule because I'm going to have multiple targets in the backend pool, and I'm going to route those based off of the path. And then I'm going to specify my listener. I'm going to call this my listener 1, and then I'm going to tell what front-end IP to listen on, the public, and then I'm going to specify whether or not I want to use HTTP or HTTPS. If I select HTTPS, we see it updates to 443 here for HTTPS traffic, and I can upload my certificate for that SSL so that I can do this SSL offloading to the application gateway itself so that it will terminate, and I can just have that private traffic going on in the back end. Now additionally, with the listener type, I can use a basic or a multi-site. And if I use a multi-site here, what I can do is actually have one public IP serving all of the traffic for multiple domains. And what I'll have is it listening here for a specific host name, and it'll route traffic based off of that using just this one IP. We're going to have just a basic here and HTTP. And then I'm going to click into backend targets here. And then I'm going to select my default backend pool because this is going to be my default target. And then I'm going to create some new HTTP settings here. I'll click add new. I'm going to call these my HTTP set. And here I'm going to specify my backend protocol, either HTTP or HTTPS, and the backend port. And this is going to be determining what kind of backend settings I'm going to have after we've gotten past the application gateway and it's handling traffic in the backend. Do I want that to be HTTP or do I want that to be HTTPS for secure? I'm going to use HTTP here, and then what we can do is additionally enable cookie-based affinity so that we can have sticky sessions based off of cookies to keep our users on the same virtual machine as their session has begun on during the entire session. We can also enable connection draining, and this allows us to remove backend pool members during planned service updates. We'll go ahead and leave both of these disabled here for creating a path-based rule here. We have our default target that it's always going to route to, but then we're going to have a path, and what we're going to HTTP set, and then the backend target. We're going to go off and create this here, and then we're going to copy the click create, and it's going to go off and create the app gateway using alt target routing with our app gateway app IP address of that public IP for our app. After about validate this, so it'll route to that second virtual machine pool. So we successfully set up our app gateway running behind the app gateway. Now the last thing, that application firewall capabilities. All my time for now. Thanks so much for joining me in this lesson, and I look forward to seeing you in the next lesson. Hey and welcome, gurus. I'm Chase, your Azure training architect, and in this video lesson, creating an app service plan, we're going to be talking about what an app service plan is, how it is used to provide the computing resources underlying a web application that is deployed in the Azure cloud, and then we're going to go through a demonstration where we will create an app service plan. Inside an app service plan, define Finds a set of computers. computing resources and the features that are available to a web application that is running on this. App service plan. An app service plan is comprised of various components, and these are the region where we want to deploy our application, the number of virtual machines that is running under a plan, the size of the virtual machines that are running under the plan, and the pricing tier that we have selected for our app service plan. And this can be free, shared, basic, standard, one of the premium tiers, or isolated, each with their own features and compute resource availability for web applications running on our app service plan. Now, with our app service plans, there are really just three main compute types that are available and determined